Joe Gallagher from Veritas Education, and this is Troubleshooting Tape Devices and Media. In this lesson, we'll begin with a high-level overview of net backup device troubleshooting. We'll talk about common issues that can arise with net backup tape devices. We'll discuss how media and device selection works in net backup and how that directly relates to troubleshooting out-of-media errors. Then we'll move on to talk about specific media-related status codes, and finally how to troubleshoot frozen and suspended media. Let's begin by discussing net backup device troubleshooting. This slide shows the initial device troubleshooting checklist for net backup. Like a lot of troubleshooting scenarios, we begin by collecting as much information about the error as possible. When did it occur? In an existing environment or a new installation? Was everything stable beforehand, or were we in a period of change where we were upgrading software or upgrading devices? Is there anything that's different that might explain for the errors that we're having? And are we sure we've checked compatibility? Hardware compatibility, in particular with tape devices, is important to make sure net backup supports the devices we're trying to use with the particular platform that our media servers and master servers are working on. If we're pretty sure that we've satisfied compatibility requirements, then a troubleshooting process is one where we begin at a low level and work our way up. And we begin at the lowest level, which is the physical level, to make sure the devices themselves are working. Are they powered on? Are they accessible? In other words, is the SAN zoning correct so that the servers can see the devices? Are all the cables and switches that may be involved seated properly and configured properly? If everything at the physical level looks good, we can move up a level to the operating system. Is the OS correctly configured, and do these devices show up when we run the appropriate OS commands? If the operating system can't see your tape drive, net backup is never going to be able to, so that's a deal breaker. If we're certain that operating system level configuration has been done successfully, we can take a look at the drivers that we're using. Now, depending on your platform, some platforms use drivers that are provided by net backup. Others use drivers that are provided by the manufacturer or the default drivers by the operating system. The net backup device configuration guide, which is one of the manuals that's available, goes into quite a bit of detail about this and lets you know exactly which drivers you should be using. If everything looks okay at that level, then the next level would be to move up to the application level, to the net backup level, to make sure net backup is properly configured to work with your devices. Here's a look at the net backup hardware compatibility list, which is available online from the net backup support site. And it goes into very specific detail about exactly which tape devices, the libraries and tape drives, are supported by net backup, and if there's any gotchas like what platform they're supported on or what version of net backup you have to be running at a minimum for support for the device. We always want to verify that whatever devices we're trying to use are supported with net backup before proceeding. Once we've done our compatibility checks, we move on to tests at the physical level, making sure that the device is functional, making sure it's correctly attached to the net backup servers. And there's a number of places that provide utilities that will be useful for this. The vendor themselves will oftentimes provide a web-based interface that you can use to connect to a tape library to be able to test its function, make sure that it's mechanically functional. The operating system oftentimes will provide commands such as MT in Unix and the device manager in Windows to confirm the function and the availability of devices. And there are also utilities that ship with net backup, such as RobTest, that we'll take a look at in this lesson, that can verify that the device is physically functional. Once we're sure that the device is functional, we then want to check and make sure, is it visible to my host, and is it configured correctly? And here's where we start to get very platform specific. And so this slide is showing examples of operating system-based device verification using Linux commands to be able to verify that the device is present, to verify that the drivers have been loaded, and also to check the status of the device. Now, the commands that you use will vary, on different platforms. On Windows, for example, we'd be going to the device manager to do these sorts of checks. Again, the device configuration guide in net backup is a great source of guidance if you're not that familiar with tape-related or device-related commands on the platform that you're supporting. Here's some more Linux examples of confirming that your devices are visible to the operating system, which is mostly a matter of browsing over to the dev tree on any Unix or Linux system and making sure that you can see the device files for the appropriate devices. And we're taking a look here at the SCSI generic devices. Tape libraries will show up under this category as generic SCSI devices. And then we're taking a look at our tape devices, which show up as NST under Linux. NetBackup uses the SG driver, the SCSI generic, and the ST driver, SCSI tape. Now here's again where you'll see some platform-specific differences. Recent Linux distros will tend to have the SG and the ST driver already pre-installed. Older Unix versions, like Solaris, might not. Solaris has got ST by default, but it doesn't have SG. So in those cases, NetBackup is providing an SG driver. Again, these kinds of platform-specific differences are discussed in the device configuration guide. But the big thing is, what I want to be able to do here is see that the devices are visible to the host. And then I can get some additional information on Unix and Linux systems by using the MT command. MT should be able to return the status of the tape drive, and you can see examples here of what it would look like with and without a cartridge in the drive. Here's another example of device verification, this time on Windows. So from the Windows Device Manager, we should be able to see that two categories of devices are present. The tape library, which will show up as a medium changer, because that's the real device that needs to be manipulated as far as the operating system is concerned, is the robotic arm inside the library. So that's a medium changer. And then under the tape drives category, we should see our drives. And we should be able to right-click on these drives and check their properties, and to be able to verify which driver they're using. We generally recommend using the manufacturer's driver in Windows. In days gone by, Veritas used to write tape drivers for Windows, but we haven't done that really in a very long time, not since the advent of 64-bit operating systems. So manufacturer's drivers are generally preferable. The Microsoft drivers can be an issue because they often don't support device serialization, which is a firmware-based feature that allows NetBackup's device configuration wizard to discover the position of the tape drive in the library. Not just discovering that it's there, but discovering where it is in the library. Our wizard needs that info to configure the device properly. Manufacturers' drivers tend to always support this. Microsoft drivers, sometimes they do and sometimes they don't. And obviously, you'll go with the driver that works the best. I have had folks tell me, hey, the Microsoft driver works awesome and the manufacturer driver doesn't really work so well. So okay, by all means, use the one that works. But our default recommendation is the manufacturer's drivers. And then I can also use the wmic command to list tape drive device information. And NTTTU is a NetBackup utility. This is not a native Windows command, but it's designed to provide the same functionality that MT does on Unix systems. Here's an example of using NTTTU in Windows. Again, this is a NetBackup provided utility, so you'll notice the binary is located in the Veritas path. And I'm using this here to do the same kinds of things I was doing with MT in the previous slides, to be able to show the status of a tape drive with and without a cartridge in the drive. This gives me confirmation that the drive is visible to the host, and the host can make a connection to it, and that it appears to be mechanically functional. So this is a useful command for manipulating the tape drive at a low level, again, just to verify that this is not the problem. We're kind of working our way up the troubleshooting checklist, crossing things out as we go. You can also verify that the operating system can see the device by using NetBackup utilities. TP AutoConf can be used to discover robots and tape drives. TP AutoConf has got both reporting and configuration functions. This is the command that you'd use from the CLI if you wanted to run the device configuration wizard, for example. The scan command never does configuration, like the name implies. It just does scan, and it returns quite a bit of information about either the medium changer or the tape, depending which argument you use. Lots of great detail here that can be helpful in troubleshooting device configuration scenarios. A classic use of this would be during device discovery, when devices were not necessarily discovered by the operating system in the order that the drives were present in the library, and I was uncertain which device file mapped to which drive position. You know, this device over here, RMT0 in Solaris, is it really the drive in position 1 in the library? Well, it might be and it might not be. So by using the combination of the output from scan-changer and scan-tape, I can identify the relationship between the device file and the position in the library and the serial number, which ultimately, is what really uniquely identifies each device. Here's examples of the output from the tpaautoconf command and the scan command. In the case of tpaautoconf, here's what you see when you look at tape drives and robots. In the case of the scan command, scan actually produces a lot more output than we're showing on the slide here. This has been truncated so that it fits on the slide. Here's another example, this time on a Windows host. The primary difference you're going to see on a Windows host is that instead of seeing a device file like NST0 that you would see in a Linux system, on Windows you're going to see a SCSI path identified as a port, bus, target, and LUN for both the robotic library and for the tape drives. Scan is extremely useful because it provides all of this information in one place, which is actually difficult to find on Windows hosts. In the device manager, you can see the bus, target, and LUN, but you wouldn't be able to find the port that a tape drive was using unless you went digging around in a registry, whereas Scan pretty much discovers all of the important properties of the tape drives and robotic libraries. It's a terrific utility. As a final high-level check, I can verify that devices are present from the NetBackup console. And this shows a scenario where the devices have already been configured in NetBackup. And so I should be able to go over underneath devices to drives to see my tape drives, and under the robots node to see my robotic libraries. Another very useful thing I can do from the admin console are to run the robot and drive diagnostics, formerly known as the qualification tools. These are utilities that were used in NetBackup's hardware compatibility lab to verify the compatibility of tape devices, and they're available for administrators' use through the console. The robot diagnostics is just going to run in the background and check the ability of the medium changer to respond to SCSI commands. The tape diagnostics is actually going to show up as a job in the activity monitor because there's going to be a tape mount. It's going to take an unassigned tape in the NetBackup volume pool for its testing of the tape drive. And that means it's going to relabel a tape, it's going to rewind, fast forward, read some data, write some data, so it needs a tape to do what it's doing. You have to have an unassigned tape, a blank tape, and it has to be in the NetBackup volume pool. It can't come from scratch because this is a destructive test. It involves relabeling the tape, which would erase any data that was on there. In addition to the commands we've already looked at, there are a number of different device verification commands that can be run from the CLI in NetBackup. tpconfig can be used to display tape and robotic library information. Those of you who've done CLI device configuration in NetBackup know that that's also the main command for configuring the devices, as well as reporting on them. And then there are various other commands in NetBackup which can return useful information about your devices. Few of them are as comprehensive as a command like scan is, but maybe they're kind of giving you the right output for what you're looking for. Details on all of these commands can be found in the NetBackup command summary document available from the support page. Those of you who've used NetBackup for a while may already be familiar with the robtest utility. If you've ever had to troubleshoot device configuration problems with support, you may have used this tool. It's commonly used. What it is robtest is really a wrapper that causes NetBackup to launch a library-specific utility to do some low-level testing. So you'll notice in this example here, we ran the robtest command, and Windows example here, it kicked off a tldtest.exe. So the little program that actually executes is specific to the library type. This is a TLD library on a Windows server in this example. And the fact that robtest connects to the library at all says to me that I've got connectivity to the library. So that's nice. I've proven that. And then I can use it to do some low-level manipulation, again to verify that the library is responding properly to commands. And so the mode command over here returns the mode sense. In other words, information that robtest is receiving from the library and some general details about the library. Now, I've moved on. You can see they've highlighted in red what the actual commands are. So I'm moving a tape from slot 1 to drive 1, and then I'm checking the status so I can see the tape in the drive, and then I can see through status of slots that the tape is no longer in the slot anymore, and then I can unload it from the drive, and then I would probably repeat the move command to move from drive 1 back to slot 1. Now, of course, in day-to-day life, it would never be necessary to run these commands, but I'm doing it here because I'm trying to validate that the library is functioning properly and that it's responding appropriately to NetBackup commands. This all helps me verify that it is properly configured, because robtest uses your NetBackup configuration for these commands that it's sending. robtest does have a few quirks to it that are important to understand. Notice, for example, that there's no prompt. When I issue a command, like move a tape from slot 1 to drive 1, robtest comes back and says move medium complete. But I don't get a $sign or a pound sign or any kind of a prompt, and that can be confusing the first time you use the tool. If you're sitting around waiting for a prompt, you're going to be waiting for a long time because there isn't one. Watch for the statement instead that says that the previous command was successful. Also, another important gotcha about robtest is that it makes an exclusive SCSI connection between this host and the library. While robtest is running, nobody else is going to be able to access that library, including the rest of NetBackup. And so if I leave robtest running in my production environment in a terminal window or a command window on Windows, and I get busy doing other things and backup jobs want to run, they're all going to queue up until they time out and fail. Nobody's going to be able to get to the library as long as robtest is running. Use with caution in production. Make sure that you exit properly from the tool. Here's another robtest example, this time entering debug mode, which allows us to return detailed attributes about the library and the values for some library-specific settings. A lot of times this is similar to the kinds of information that you could get using the vendor-provided tool to connect to the library to check and set these settings. But again, it gives me a nice feel-good that NetBackup is communicating properly with the library if I can retrieve these settings. As I'm moving along in my troubleshooting process, I've validated that the operating system can see the device, it's configured properly, the correct driver is being used, the NetBackup servers can connect to and manipulate the library using robtest. The next level of troubleshooting then is, let's see if I can do a tape mount and unmount, and let's do it manually outside of a backup job. And so the TP-REC, which stands for tape request command, is used for tape mounts. I can invoke that manually from the command line, just specify the media ID of a tape that's in the library, the density of that tape, and a temporary file name. And what will happen is NetBackup will mount the tape. It'll show up as a tape request in the activity monitor, and the tape will remain mounted until I unmount it using the TP unmount command. The purpose of that file name, by the way, is that while the cartridge is mounted, any data that was written to the file name is written to the tape. It's sort of like the mount point for a tape device. That's really how all tape operations work in the background. So what I'm looking to do here is I'm looking to verify that NetBackup is properly mounting and unmounting tapes. In this next topic, we'll take a look at device-related issues at the NetBackup level. At this point, we've gone through and checked the physical level, the operating system level, the driver level. Everything appears to be good. So we're starting to wonder if our problem isn't a level higher at the application level. And so we're going to take a look at the net backup level and see if that's where the problem is. Net backup needs you to configure tape drives and robots properly in order for it to function. And this behavior here with needing to configure tape drives in net backup is a little bit unusual because for most devices that are attached to a server, we don't do application level configuration. For your disks, for example, there's no disk configuration in net backup. The operating system sees the disk. When NetBackup wants to write data to a basic disk storage unit, it says, hey, Windows or Linux or whatever platform I'm running on, here's half a terabyte of data, go put it on that disk over there. And the operating system, just handles it for you. Tape devices are different. With tape devices, the application, NetBackup, is going to be sending low-level SCSI commands to mount tapes, position them, rewind, fast forward, read and write data, and so NetBackup needs to be properly configured in order to send these commands. And the process of configuration is mostly a process of telling NetBackup two things: where the device is located and what type of device it is, what language to speak when I talk to it. So if there are misconfigurations at the NetBackup level, it probably affects one of those two things. Either the location of the device is incorrectly specified, or the type of device is incorrectly specified. And this slide gives us, some suggestions for things to consider at the application level. Now, if the drives are marked as being down in NetBackup, that means that they're unavailable for NetBackup's use. Up drives are available, down drives are not, and that's a NetBackup thing. It doesn't necessarily correspond one-to-one with the tape's actual physical status. Now, if a tape drive fails and sends a tape alert signal to NetBackup and says I'm busted, then that will result in the drive being marked as down. But there are other times where, just due to flaky communication issues, a drive goes down just because there's a SAN hiccup and NetBackup can't talk to it for a while, even though the drive is actually healthy. And so it requires investigation. Other things that they mention on the slide here, possibly missing license keys, especially if you're using the shared storage option in NetBackup, out-of-date device mapping files. These are things we're going to talk about in subsequent slides, how to troubleshoot them. Here's an example of one place where we can potentially misconfigure our devices, and that's if we misconfigure the robot drive number. The robot drive number is the drive's position in the library, where it is physically located. Now, sometimes, the world is nice and drives get discovered by the operating system in the order that they're present in the library, so that the OS level identifier for the drive, like tape 0, tape 1, tape 2, corresponds directly to the drive's position in the library. But that's not always guaranteed to happen, depending on your physical topology and depending upon the operating system, whether it does, for example, multi-threaded device discovery at boot time or not. And so if we're manually configuring our tape drives, we might make an error here if we're not sure which drive is in which position. And the process itself can be a little inherently confusing because a lot of tape libraries identify their drive positions starting with 1. So a library with 6 tape drives might say they're in positions 1 through 6. And the problem is the operating system will usually start numbering devices at 0. So in Windows, for example, that'll be tape 0 through 5. So tape 0 is position 1, tape 1 is position 2. It's off by 1. So there's a kind of a built-in ability to confuse yourself. And just to add, another potential gotcha here, not all libraries behave like that. Some of them start numbering their positions at 1. Some of them start positioning their numbers at 0. Some of them allow you to change it using library manipulation software. And so if I'm ever not sure which drive is in which position, before I do any kind of device configuration, I should make sure to find out, and scan is your best friend for doing this. Like we mentioned earlier in the lesson, using scan that gets a detailed output of your tape drives and your library will allow you to make that association of the OS identifier to the drive position to the serial number. Remember, again, all of these things like the tape 0 and tape 1 in Windows, or devrmt 0, devrmt 1 in Solaris, all of these operating system monikers are relative. You could remove a tape drive and reboot the server, and those could change during device discovery. Serial number is not going to change as long as the device is physically present. So at the end of the day, that's really how we uniquely identify our devices. And so scan helps us out with that. This robotic drive number mismatch is something that can be encountered fairly common when you're manually configuring devices, either from the console or if you're doing it from TP-config from the command line. It's a little less common if you use the device configuration wizard, because as long as the driver supports drive serialization, the wizard should just be able to automatically discover the correct position of the drive without you needing to know that information. Which is one reason why these days we recommend using the device configuration wizard in the console to set up your tape devices. This is an example of a platform-specific device configuration problem in NetBackup. We're using Solaris as the example here. It's a good example to use because unlike some of the more modern Linux distros, Solaris does not come with a SCSI pass-through driver by default, that SG driver. That driver is supplied by NetBackup, but it needs to be configured. And so there's a process we go to configure the SG driver and the ST driver in Solaris to be able to see our libraries and to be able to see all of our tape drives, because by default it'll usually only be able to see some of them. You also see examples here about how to prevent Solaris from unloading drivers from memory by editing the etc system file, and a reminder about which device file to use, which in Solaris we always want to use the CBN device file. If you browse over to the device tree on any Linux or Unix system, you'll usually notice multiple device files for each device, and which specific file you use turns on or off specific features. If there's still only one devrmt0, but devrmt0 will probably have several files with different characters appended to it. And in each platform that NetBackup supports, there's only one that NetBackup wants to use. The device configuration guide will tell you specifically, if you're running Solaris, use the CBN driver. And in this example here, C for compression, B for Berkeley style stops, which has to do with how NetBackup writes the tape marker, and N for no rewind. After writing data to the tape, don't spin it all the way back to the beginning. Stay where you are so we can quickly and easily append more data. So it's not like there's a decision to be made here as to which of these device files I need to use. The device configuration guide will be very specific. Use this one. In Solaris, use CBN. If I use one of the other ones by mistake, I'm going to run into issues later on. I'm probably going to run into drive positioning errors or other sorts of problems if I use the wrong file. Incorrect or missing license keys can be a problem where NetBackup refuses to do drive configuration on a particular host. And so we need to have the library-based tape drive visible. If I go to Help and then License Keys, I should be able to see that there. And that's the ability to set up any tape drive on this host. Now, if I'm using shared storage, which the SSO is a common option in NetBackup, where I have multiple SAN-attached media servers that are sharing access to a particular tape drive, that SSO license key must be installed on each media server. And so that can be a gotcha there. A lot of licenses in NetBackup only need to be present on the master server. For SSO, this key needs to be present on every media server that's going to be sharing the drive. If the key is not there, then I'm not going to be able to do configuration. When you're checking your keys, remember if you want to use a command line bpmin license to run on a specific host, that's probably the best way to do it. If you're going to use the console, make sure the console is pointed to the correct host. In other words, if you want to check and see if media server number 2 has an SSO license or not, the console has to be directed to media server number 2, not to the master server. If you're pointed to the master, you're going to see the master server's license keys. So keep that in mind, because that can be a frustrating thing, especially when you're troubleshooting this late at night. Another thing to verify is that the media server's name is listed correctly in the bp.conf file or registry, depending if you're on Unix or Windows. Also, if the vm.conf file is present, which it might or might not be, it's Windows or Unix, but there's not a lot of information in it these days, so it isn't always present. Depends on the features that you're using. If vm.conf is present, then you do want to confirm that the server name is there and is correct for that host. If the vm.conf file is not present, that's not necessarily a problem. A lot of times it isn't. Also, when media servers are first set up in NetBackup, they're registered with the NetBackup database on the master server. And this is something that should happen automatically when you configure the server. If for some reason the master is unavailable at the time you do the media server install, this registration might not take place. And so it can be done manually later on by using the nbemm command. So using nbemm command -list hosts -verbose should show me which media servers are configured in my environment. And this is a command, by the way, you should be able to run on any master or media server in your environment. That's a nice way of verifying that a media server is able to connect to the master server and read the NetBackup database. If this command won't run on a media server, you know that that's a problem. If you check the output and you see that a particular media server is not listed as being configured in your environment, even though it should be, here's the syntax down at the bottom to manually add a media server to the NetBackup database. You'll notice it's kind of a long syntax there. All that stuff is actually mandatory. Another potential issue is an out-of-date device mappings file. This mappings file is used by the NetBackup device configuration wizard to properly discover and configure new devices. If you've got a relatively new library and your mappings file is not up to date, then we may not have the correct information on hand to properly configure it. A new version of the device mappings file, the most up-to-date one, can be downloaded from the NetBackup support page, and then I use the tpext command to load that into the database. They show you the syntax here using tpext to check your version. It's the same command that you would use to load a new one into the database once you've downloaded it from support. And note that although device mappings file traditionally is associated with tape libraries, it's also used with OST appliances. So that's also potentially troubleshooting there if you've got a new appliance and you're unable to configure it successfully. Check your device mappings file. Another troubleshooting step at the NetBackup level is to check your media server status. Media servers typically should be in the active state, and any media server should be active for disk at any time. If a media server is going to have tape devices attached, then it should show up as active for tape and disk. If for some reason it shows up just as being active for disk and not for tape, that means that the LTID daemon is not running. And LTID is the device manager daemon in NetBackup. It means that either you have not configured tape devices or you haven't configured them properly, or it means that the daemon has abnormally terminated if the server shows up as just being available for disk. Being available for disk is confirmation that the NBRMMS service is running, and that should be running all the time on every media server, whether you're doing backups for disk or not. And so if that's not running, then you have a problem. Now, if media servers show up in the offline or deactivated state, offline is another example where a daemon is not running that should be. In this case, the VMD daemon. Volume Manager, which manages your tapes, but is also used for communication between media servers. VMD is an important communication process. It should be running all the time on every media server, and if it's not, they'll show up in the offline state. You should consider license keys as a potential culprit here. One of the ways in which NetBackup enforces license keys is the VMD daemon refuses to start if the license is not valid. So consider that as part of your troubleshooting. And if a server shows up in the deactivated state, that usually is a manual action that's been taken, where an administrator has taken a media server offline for maintenance. You can do this on a right-click right from the device monitor in the admin console. You can activate or deactivate a media server. You can also do this from the command line using vmupper command. If you've swapped out a device that has failed, such as a tape drive, once the device has been replaced, the NetBackup database should be automatically updated with the new information. Now, if for some reason that automatic update doesn't happen, you can manually reconfigure your devices at any time by using the Configure Storage Devices wizard. And this wizard will go through, and by default it will probe all of your media servers and discover all of the tape devices and configure them properly. If you don't actually want to scan all of your media servers, you'll notice in the part of the wizard, the first screen that comes up indicated with the number 1 on the slide here, it shows which hosts you're going to scan. Maybe some media servers don't have any tape devices, so I don't want to scan them. Why waste time? You can always uncheck hosts that don't need to be scanned. But any host that does have tape devices can be safely scanned by the wizard, and basically it just redoes the configuration. The device configuration wizard in modern versions of NetBackup is quite reliable and usually does a very good job properly configuring devices. It is the recommendation from engineering that this is the default method used anytime you need to configure or reconfigure tape devices. Another method of handling replaced devices is to use the tpaautoconf command. tpaautoconf can be used to report on discrepancies. And a discrepancy happens when NetBackup doesn't realize that a device has been switched out, but it does notice that suddenly the serial number on a device has mysteriously changed. That will show up in tpaautoconf-report discrepancy, and the tpaautoconf can be used with a -replace to replace a medium changer or to replace a tape drive. This is not the recommended way of doing it. The recommendation is to just delete the drives and then use the wizard to do the reconfiguration from scratch. It's always nice to start off from a clean slate. But if you'd rather not do that, if you would rather only have impact on a particular device, just the one tape drive that's been swapped out, here's a way to manually do that. From time to time, NetBackup may receive tape alert messages from your tape drives. Tape alert is an industry standard way for intelligent tape drives to send messages to applications like NetBackup about their status. It was originally developed by Hewlett-Packard, but it's pretty much become the norm for all tape vendors these days. So NetBackup, when it receives tape alert messages, may take actions based on the message. Most tape alert messages you might get are usually bad stuff, and so the majority of tape alert messages are for a drive that's either dirty or failed. So if the drive is dirty, it will trigger NetBackup to see if there's a cleaning tape in the library and to automatically mount it and do a cleaning the next time it's available. Or if the drive indicates that it's failed, then NetBackup will mark it as down. Now you can see this kind of activity. The errors log, you see the path of that for Unix and Windows on the slide here, tracks actions that NetBackup has taken, like downing tape drives because of tape alert messages. You can also see tape alert messages in the system log and in the BPTM debug log. And so if you ever run into a situation where tape alert messages are being fired off by the device, even though the device is healthy, and so NetBackup is downing a healthy tape drive because it's erroneously sending out these signals, this can help a lot with troubleshooting. Because one of the troubleshooting things that you have to go through is when we're getting tape alert messages, who's really at fault? Is the device actually bad, or is NetBackup doing something it shouldn't be doing? This helps a lot in collecting evidence to find out the root cause of the problem. This slide shows an example of checking the details of a drive, which you do by right-clicking on a drive in the console to verify that tape alert is enabled. It will be enabled by default. And there are listings in the NetBackup admin guide that show what actions NetBackup will take when it receives signals, tape alert messages. There's a snippet of that on the slide here, and you can pretty much see that, again, there's two categories of messages here. There's the I'm dirty, there's the I'm broken. And so dirty drives get cleaned, broken drives get marked as being down. If a tape alert message is sent about bad media, then NetBackup will freeze that tape. Sharing of tape drives, or SSO, is a commonly used feature in NetBackup. So I've got two media servers in this example, and I've got one tape library, and the library is visible across the SAN to both media servers, and so the drives in that library are easily shareable devices. Now note that in that case I really have two paths to each tape drive, one from each of these media servers. And you notice in NetBackup in the activity monitor that we have the little hand underneath the drive to show that it is a shared drive. That's something we borrowed from the way Windows Explorer used to show shared folders. And if I take a look under devices in the admin console, I should be able to select one tape device and see in the lower pane the two hosts that are sharing it, and I can see who the scan host is. The scan host is the default host that'll be sending a heartbeat signal to this drive periodically, even when it's not in use, just kind of pinging it and making sure it's still out there. Typically, the scan host is the first host that comes up when NetBackup is started. In this example, the master server is the scan host. It doesn't usually matter who the scan host is unless you get into a scenario where you have one NetBackup server that is particularly busy and really overburdened, and it's not responding in a timely manner to commands. That can really kind of gum up the works for drive sharing. And so there is a property that media servers have that's visible with the NBEMM command from the command line called scannability, which regulates how likely a particular server is to be the scan host. And so if I reduce a server's scannability, it is less likely to be the scan host. I might have to do that if I have a super busy server. Setting the scannability to 0 means it will never be the scan host. Somebody else has to do this function. Again, being the scan host is not a lot of work. Don't think about it that way. It's only a problem if the server is already too busy. Here's an example in an SSO environment where I've had a communications failure, maybe a cable failed, and so one of these media servers has been cut off from these two tape drives, but the other media server can still see them okay. And so in the NetBackup console, in the topology view, I'll see the tape drive in this funny sort of up-down state, and when I do more investigation, when I click on the drive, I'll be able to see that this is up on the first host and down on the second host. Now there can be a number of reasons why this happens, but typically communication, bad cable or bad switch is usually going to be your culprit here. Here's an example where one tape drive is down, and let's say in our example here it's because of a mechanical failure. And so in that case, all paths for the tape drive will be marked as being down. This drive sent a tape alert message that says, "I'm busted," and so everybody goes down, and that's where we see just the big red arrow in the topology view of the server. As we've mentioned before, we can get into problems if the proper NetBackup processes and services aren't running on the correct host. This slide is a great little summary showing which media manager processes should be running on each server in your environment. And it's sort of, you look at this as the minimum, so at a minimum, VMD needs to be running on every host. Any master or media server that's not running VMD is having problems. Other processes, like LTID, the device manager, is only run on devices that are controlling tape drives. And so any media server that's using tape for backups should have LTID running, and the robot control host should have LTID running. The robot control host is the host that's actually talking directly to the library. Remember that in an SSO environment, the tape drives will be shared. The medium changer will not be. Medium changers are not shareable devices. I have one server in my environment called the robot control host that is really controlling the robot, and what we really mean by that is controlling the medium changer. And so some of these lower level media manager daemons, TXXCD and TXXD, that's not the actual names of these processes. The actual names of these processes is based on the library type. And so if I'm using a TLD library, I'll see TLDCD and TLDD. TLDCD is the robot control daemon, so we want to see that running on the robot control host only. TLDD, the robot drive daemon. Anybody who is doing backups to tape should have that daemon running. We need it for the tape mount process. Same thing with AVRD. Is necessary not so much for the tape mount, but for reading the barcode once the tape is mounted. And again, you'll notice in the slide here, the master server only needs to be running VMD unless it's doing backups to tape. If the master server is functioning as a media server doing backups to tape, then it needs all of those processes that are checked off under media servers. As noted on the slide, debug logs can be enabled for all of these processes. They're created in the Vol Manager debug directory. The debug directory does not exist by default. You create the debug directory the first time you want to turn on logs, and then you use subdirectories under debug for the particular Media Manager processes that you want to log. We've talked a lot about device troubleshooting so far in this lesson. We're going to start shifting a little bit and discussing issues with media. And we'll begin with a discussion about media and device selection. This slide shows the media and device selection processes on the master server. Essentially what happens is the job manager, the high-level process on the master server that's responsible for executing jobs, reaches out to the resource broker and says, hey, I'm going to be creating this job, and these are the resources that it's going to need. The resource broker is responsible for keeping track of which resources are available and polling down the queue of queued jobs in the activity monitor, looking for needs that can be met. Looking for matches it can make between devices and media that are available and jobs that are looking for them. NBRB gets this information from NBEMM. NBEMM, as we've discussed elsewhere in this class, is a service container that runs different subsystems. And the subsystem that's important to us here is MDS, the Media and Device Selection. So that's who NBRB queries to discover which devices are available. It does that at the beginning of each allocation cycle. And when NBRB identifies, hey, this job is looking for a tape drive and I've got a tape drive in that library available, it's going to update MDS and say, all right, this job is about to go active and use this tape drive, so that the drive gets marked as in use in the NetBackup database. Another important subsystem in the NBEMM service container is the device allocator. The device allocator is responsible for drive sharing. And so it's the DA subsystem that manages the scan hosts for shared drives and reassigns that responsibility when necessary, and that monitors devices through the scan host to keep their status updated. And there's a heartbeat ping that's going to be sent out to each tape drive every 5 minutes, just kind of a hi, are you still out there, just verifying communication message. This slide shows an example of how NetBackup decides which tape to use for a particular backup job. This is a key piece of information to understand because it is the key to troubleshooting the status code 96, the out of media error, which is a fairly common NetBackup status code. Avoiding these error code 96s involves understanding how NetBackup decides what tape to use in the first place. And so in the example over here, we have a storage unit, WinMedia Tape STU, and we have a volume pool called server tapes. And so the storage unit tells us which media server is going to be used, and it tells us which tape library is going to be used, and then the volume pool tells us which tapes are appropriate for this job. And so when this policy runs, the EMM services on the master server are going to look for an appropriate tape. They're going to look in the server tapes volume pool to find a tape that's in the correct library that the storage unit is asking for, and it's looking for an active tape first, a tape that already has other backups on it, because NetBackup likes to fill up tapes completely before it opens up new ones. But in order for a tape to be suitable, besides being in the right volume pool and in the library and in the active state, it also needs to be the correct density, which is also a property that NetBackup gets from the storage unit. It needs to be the correct retention level. NetBackup will not mix retention levels on the same tape because doing so will usually tend to mess up your tape rotation. It's bad mojo to put different retention levels on the same tape. You don't want to have a situation where you've got one tape that's about 80% full with long-term multi-year retention or infinite retention, and then the last backup that's written to that tape is for 1 week or 2 weeks. That's just going to wind up being wasted space. You'll waste money, when you mix retention levels on tapes that are vaulted. So by default, NetBackup won't do it. The tape can't be over its maximum number of mounts or past its physical expiration date. These are settings which are not active in NetBackup by default. By default, tapes can be used forever for an infinite number of mounts. However, some places will set limits on that and says, you know what, I want to use these tapes for maybe a couple hundred mounts, and then I want to throw them away, because I know that as they age, media errors become more likely. So if you have set one of these limits, NetBackup will enforce it. And NetBackup is also going to consider media server ownership. By default, media servers own the tapes that they're using, and other media servers do not have access to them. So we're looking for a tape that's owned by the media server. So if there is an active tape in the server tapes pool that meets all of these criteria, terrific. NetBackup will mount it and do the backup job. If there is no active tape, then NetBackup will look for an available tape, which is a blank tape. And again, the tape needs to be in a correct volume pool, needs to be in the library and the correct density that the storage unit is asking for. It can't be past its maximum number of mounts or past an expiration date if I have set those settings. If there's an available tape that meets those criteria, awesome. NetBackup mounts the tape, runs the backup job. If there's no active tape and no available tape in the server tapes pool that are usable, my last recourse is the Scratch pool. Is there a tape in Scratch that is suitable? If so, NetBackup will assign it to the server tapes volume pool and my backup will run. Now keep in mind, it's not enough just having a tape in the Scratch pool. The tape needs to be in the correct library. It needs to be the correct density. It can't be over its max mounts or its physical expiration if I have set one of those settings. So it is possible to get failed jobs even though I have tapes that are in the Scratch pool. If, for example, if the tapes are in the wrong library or they're the wrong density. If there's a Scratch tape that's suitable, then good, my job is going to run. If there are no suitable Scratch tapes, that's when I get the status code 96, no media available. You should consider this slide your status code 96 troubleshooting checklist. If you're getting that error code, one of these things is the problem, guaranteed. Go through item by item and you will discover what the issue is. Let's continue our discussion about media. In the next topic here, we'll talk about media-related status codes. This slide shows some common media-related status codes. Now, we talked in detail in the previous topic about the status code 96, unable to allocate media, and what the potential causes were there. Other common codes, 83, 84, 85. 83 has to do with a media open error, where NetBackup is unable to properly mount and access the tape. The physical write protect tab might be a problem here. If that tab is set, NetBackup won't be able to open the media for writes. It's also possible that there's a drive configuration problem. If I'm using the wrong device file, for example, on a Unix or Linux system, here's where I can encounter some difficulties. 84s are a write error, so we usually see those on backup jobs, and it can mean that I have physically bad tapes, could generate an 84. It's also possible that the tape drive is dirty. It's also possible that I'm using incompatible media types. Incompatible media can actually get you an 83 or an 84, depending. 85 is a media read error, and so I normally see this on a restore, where NetBackup is unable to read from the device. This might mean that the tape is bad. Either the media has failed or it has been accidentally erased. It's also potentially caused by dirty tape drives. I should always consider drive cleaning in these examples, or by misconfigured drives. The 86 is a media position error, where NetBackup was unable to position to the correct file on the tape. In other words, we went to where we thought the data was and couldn't find anything there. That can also happen because we're using the wrong device file on a Unix system. It can also happen if data has somehow been deleted from the tape, but not expired from the NetBackup catalogs. So NetBackup's got a record that this file is there, but then when I go there, I don't see anything. This slide discusses troubleshooting status code 96 errors. Again, the slide in a previous topic is really your very best reference for this, but this is just kind of reminding you of a few things you ought to be checking, making sure the storage unit and the media type, it matches the media that we're trying to use. We can kind of refer to this, especially when it comes to the density of the tape, as the density triangle. The density of the tape, the density of the tape drive, and the density of the storage unit must all match each other. If any one of those is a mismatch, I'm going to get problems and probably status code 96s. If tapes are frozen or suspended, that can cause a problem. If I have set limits on the maximum number of mounts or the physical expiration, remember these limits are not set by default, but if I choose to set them, NetBackup will enforce them. And it won't actually tell me it's doing it, by the way. When a tape goes beyond its maximum number of mounts, for example, there's no big red flag that gets waved or anything like that. NetBackup just ignores it, and refuses to use it for backups. It's still available for reads, so I can still do duplication or restore, but NetBackup's just not using it for backups anymore. And so if you're going to use one of those settings, the expiration date or the max mounts, you should be periodically checking to see if there's any tapes that have gone over the threshold. You can do that manually, but there's also a useful report in OpCenter that you can run, say maybe once a month or so, to scan through your tapes and look for tapes that are over this threshold. The corrective action for status code 96s, usually the biggest issue is finding out exactly what the problem was. As we've seen on previous slides, there's a number of things that can cause 96s. Once I identify what the problem is, it's usually pretty straightforward to correct it. I didn't have tapes in the right library, or I didn't have tapes in the right volume pool, or the tapes were the wrong density, or they were owned by the wrong server. If I've got tapes that are in a read-only state, like frozen, suspended, imported, or full, I need to either replace those tapes in the library with tapes that can be written to, or in the case of frozen tapes, to unfreeze them. When troubleshooting the status code 83, which is the media open error, some corrective actions I can take or problems I can look for. First off, verifying my drive configuration on a Unix or Linux system using the wrong device file can result in tape opening errors. If I'm trying to do a backup and the tape is write protected at the physical level, the write protect tab on the cartridge is set, that's going to cause a problem with opening the media. If I'm trying to use an incompatible media type, I'm trying to use an LTO1 tape and an LTO4 tape drive, that's not going to work, and so that can also give me a media open error. Same thing could happen if the drive needs cleaning. Here's some suggested corrective actions. It's always worth trying to clean the tape drive to see if that might possibly be the issue. You can do that just by right-clicking on the drive in the admin console, or you can use the tp-clean command from the command line. Now, if the media type is wrong, again, if I'm using LTO1 tape and an LTO4 tape drive, that's just not going to work. I've got to use the correct media type. Usually the LTO drives will support for reads 2 generations back and for writes 1 generation back, although I won't get the same performance as I would if I was using matching generation. If the tape is defective, I got to throw it away. There's not much I can really do about that if the tape's no good. Possibly try to duplicate some images off the tape before I destroy it, see if I can at least get that to work. If the drive is configured incorrectly, then I can go through and try running the wizard again to reconfigure them. Or if I'm doing configuration manually, use the scan command to verify all of the properties of the drives before manually reconfiguring them. Lastly, we'll discuss frozen and suspended media. Frozen media is a problem state in NetBackup. A malfunctioning in the air conditioning in a server room has caused the temperature to plummet and a layer of frost has... No, I'm just playing with you. Frozen tapes are tapes that NetBackup think is bad. NetBackup thinks there's a problem with this tape and it doesn't want to use it. So frozen tape is not a writable tape. You can still do reads off of a frozen tape, but not writes. Now, what can cause frozen tapes? A number of things. Flat out bad media can cause frozen tapes. Or it might be a tape where NetBackup doesn't like what it sees on the label of the tape. So if there's a barcode mismatch between NetBackup's database and the barcode on the outside of the tape and what's actually written on the tape's label, that can cause frozen tapes. If there's backups on the tape from other backup products, if I've got Legato or Backup Exec or some other kind of data on there, NetBackup doesn't know if that data is any good or not, and so it freezes the tape. Cold catalog backups, if you happen to come across a tape that's got catalog backups from versions prior to NetBackup version 7. We used to use a different format for catalog backups than for all other types of backups in old versions of NetBackup. That might cause a frozen tape. Here are some suggestions for repairing frozen tapes, because that's always the thing. You come into work and you discover you've got a whole bunch of frozen tapes in NetBackup. There's some investigation as to why they got frozen and what can I do about it. By the way, the activity monitor and the tape logs report are great places to start your investigation for why the tape got frozen. And so if it turns out this tape has non-NetBackup data or old catalog backups on it, I can either tell NetBackup it's okay to just allow media overwrite. Maybe I used to use Backup Exec, but I don't use it anymore, and none of that data is important. Just write right over it. That's a setting I can do in the master server host properties in the media tab. Or on a tape-by-tape basis, I could relabel the tape. And that would, basically erase the tape, and then NetBackup would be happy to write backups to it. Relabeling the tape works if there's non-NetBackup data on there. It's also the way you correct barcode mismatches. Make sure you uncheck the box that says to keep the old barcode when you relabel the tape, though, to correct a mismatch. In terms of recurring errors with media, if you're getting recurring soft errors, more than 3 errors in a 12-hour period will cause NetBackup to freeze the tape. Unrecoverable errors one of those will cause it to be frozen immediately. In terms of how I address this, if I think that there's just some kind of incompatibility issue here between the current firmware level of the drive and NetBackup, and these tapes are being frozen for no reason, I could change the drive error thresholds so that NetBackup tolerates more errors before freezing the tape. That's generally probably not the right decision to make unless you're sure that that's the issue. Most of the time, recurring errors with media means bad tapes. Bad tapes should be discarded. The cost of the media is trivial compared to the cost of potentially losing data. Lastly, the robotic device number and tape device mismatch. I can verify this by using robtest. If I tell robtest, hey, take this cartridge out of slot 1 and put it in drive 1, and robtest sticks it in drive 2 instead, that's a classic sign that I have messed up my robot drive number in my configuration, and I should go back and correct that. Suspended media is also a read-only state. I can do restores or duplications, but I can't write to these tapes. Now, suspended tapes, unlike frozen tapes, are not a problem state. Suspended tapes are usually something that's been done deliberately. When I'm planning on sending a tape off-site, and I want to make sure that nobody writes to this tape while it's off-site, suspended is kind of like a software-only write protection for the tape. A lot of folks who send tapes off-site will both suspend the tapes in NetBackup and set the physical write protect tab on the cartridge itself, which is a very good idea, again, just for maximum data protection. If you're using the NetBackup Vault add-on, Vault will, by default, automatically suspend tapes that are going off-site. And a suspended tape is not a permanent state. Suspended tapes will remain in that state until all of the backup images on them have expired. When the last backup image on the tape expires, the tape state automatically changes from suspended to available, and that's a sign to me that I can now rotate this back on site and reuse it. So generally, suspended tapes are part of normal operations, not necessarily a problem. I can suspend or unsuspend tapes anytime I want to by right-clicking on them in the admin console or by using the BP Media command. In this lesson, we learned about the device troubleshooting process, how to troubleshoot tape libraries and robots at the operating system level and at the NetBackup level, and we also explored the media selection process by NetBackup and discussed some common media-related status codes.